It's me, Draft Science video, yay. Anyway, probably do a little bit of Slit stuff since that's what I've been working on. The writing of the papers. Going a bit slowly, I have to concede, which is annoying. But before we go to that, we'll just go through the short list. Oh, yeah, that's right, I have a comment I gotta take care of too. Anyway, a couple of questions asked by a friend. Anyway, the other cranks, physics cranks, whatever you call these people, God, they're all so bad. And people post me, links to them, like, oh, hey, this guy's really got something, blah, blah, blah. So anyway, somebody posts a link to this Gavin Wince guy. Jeez, does he make you want to wince. So he's got a 3.5-hour documentary. 3.5 hours. He did an okay job. He took clips from other people's videos and sewed it all together into a big pile of, what the fuck are you talking about? Time has 3 dimensions, blah, blah, all kinds of wacky shit. But the funny thing is there's always little moments where they almost get it, and you say, oh, you were almost there, fella. You almost had it right. But you say, oh, well, once I thought of creating a field, and you're just like, yeah, that's the idea. That's it. Push, not pull. But anyway, time isn't even a dimension. He wants to make 3 of them. This will be one of the papers, will be this whole idea of how can you possibly dimensionize a function. Shoes, and then like walking, different things. Shoes are a thing, right? And the walking is something else. Yeah, it's just they're just you can't say walking is just another dimension in which shoes travel or something. It's just stupid. It's stupid. Even the whole space thing. We already have forward, back, left, right, up, down, right? And you're already saying there's already space in that dimension. Space already is there. You can't make a separate dimension of space because space is already in the 3 dimensions. And if you just give it a tiny bit of thought, you say, well, time is already in there too because of that constancy of the speed of light. That speed limit says, yeah, all this stuff takes time. Done. There's no dimension. Well, anyway, there's no point in me saying this stuff because nobody's listening. And when they do listen, they say something stupid. Well, what about this guy? So anyway, so the other idiot, some other idiot posted a link to the stupid Bill Gatey guy. And I've already done videos to him, and I sent him an email, and he sends back just his usual shtick. It's ropes, rope. Everything's connected with ropes. You're just, what are you talking about, you fucking cunt? Ropes made out of what? Stork feathers? Just, everything connected to, in some of these theories, it's like string theory. They're such cheats in a way. Because, yeah, if you tie everything together, then you can do the backward thing. You can just say that everything that got in the current condition got that way because the rubber band's all stretched. And that way you can just let go of all the rubber bands and see it go backwards. So there's a certain, it obeys the first rule, which is that you can't go forward without having somehow a way of going the backward again. It's almost like the quantum thing is a little bit undone by that fact, is that the math works going backward, and so you're saying you can figure out that the photon went through one slit with the math going backwards. So anyway, but it's just silly. There's no ropes that are more complicated than the photon. A photon's connected to something with a rope, and you're just like, well, that a rope that's 7 billion miles, 7 billion light years long. You're just like, come on, come on. You can do better than this. Apparently you can't, so you see you could do better than that? No point. So then the other guy is this, whatever, your Papadopoulos guy. And he just does all this ragging. It's just, and like I said, he apparently has me blocked, and he's talking like, yeah, I always win my debates, and I'm always way ahead of all you people, and he doesn't want to take on the challenge, pussy. Um, yeah, but it's all this made up again. This it's a perpetration through the but that shit to obeloid. It's a perpetration in the obeloid tourniquet thingy, Bob. What? This isn't explaining anything. He's ragging on other people for describing instead of explaining. And what the hell are you explaining, shithead? Well, anyway, so now he's saying there's something goes faster than the speed of light, that light is induced. Now, I might argue that induction is an important concept. I think gravity is induced. But once it's induced, that's it. So it's slow to begin. The first little bits of gravity take a little time before you're in your full gravitational blah blah. But once you're in it, then it doesn't have to reinitiate. So it will get up to speed almost immediately. So this idea that he's saying there's faster than light, blah blah blah. Well, maybe for a zillionth of a second, and then it's back to regular light speed or something. So, what does this mean? Does this mean anything? No, it doesn't mean anything. But clearly you can't say something like, there's faster than light, and then not point out what experiment demonstrates that, because whatever experiment actually demonstrates that could be used to predict the future. Fact. I mean, the implications of faster than light just means that you could put the sensor somewhere, across the world, and I could know stuff before anyone else is going to know it, kind of thing. It just breaks the rules, right? It doesn't make any sense, is what that is. It doesn't make any sense. So obviously that's not taking place. I mean, animals would already have taken advantage of this quirk of nature, this faster than light doing, because yes, it would be a huge advantage to see the bear before he got here. yeah. Yeah, huge advantage. Anyway, so just all very bad. Very bad. And so anyway, alright, so on to the two slit stuff. Or maybe I should do the questions first. Maybe we'll do the questions real quick. I have to find my Skype and such. Alright, let's see. I didn't understand your flat model of arrows. Sometimes your camera won't focus on the point of it. And I had a few questions. Are these arrows standing for elementary particles with the arrow's direction going the speed of light? Yes, the only elementary particle. There's only one elementary particle. Photons are one of these. Photons are a variety of the elementary particle, and they're exactly like the gravity particles, with the difference being the frequency. They come at a frequency. If you can make gravity come at you at a frequency, and the frequency just happened to be the same as light, you would see it as light. So it's exactly the same particle. So photon without a frequency is what gravity is made out of. And you can sort of understand that this frequency thing is really important, right? Because just like the gravity you don't see microwaves, you don't see the radio waves, you don't see all the cell phone crap flying right through your head right now. You don't see any of that shit. And you certainly don't see the X-rays or the cosmic rays. You don't see shit but this little tiny bit of the spectrum. Because matter, every type of atom, is sensitive to different kinds of radiation, frequency of radiation of this quanta. And everything detects gravity so far, right? We haven't found anything that doesn't detect gravity. And we sense gravity. We can feel compression. I don't know if that's really sensing gravity. That was just more about feeling the air. But regardless, it's possible to create a sensor for gravity. But what good would that be? Because it's always the same, right? I mean, gravity doesn't change, so sensing it wouldn't do you much good. And yes, you can basically duplicate that by just, we adjust to gravity. Clearly, our body does, so it's clearly sensing it. Yeah, but it doesn't have a wavelength, and it doesn't have, apparently, whatever. There's no way to see things. Usually, you have to do the same kind of frequency thing and then see how it's changed by its interactions. And so something that was coming in a scattered frequency is a lot harder to see. It gets lost. Like the two-slit experiment doesn't work with white light because there's too many colors and it just blends out all of the stuff. All the stuff gets lost in the diversity. Not a terribly important point. I mean, I don't need to argue why you don't see gravity, but you don't see it because it's not light. But it's the same entity. So that's the fundamental particle. Protons, neutrons, electrons are made of a collection of those things. Like an electron would be perhaps 1,000,000 of them, and a proton would be perhaps 10 billion of them, that kind of thing. And a neutron, 10 billion. So it would be a big pile of them all caught in a swirly. All right. For the other things we call fundamental particles. So like a quark would be like, whatever, 50,000. Just make up a number. Doesn't really matter to me. But all those stupid things they put inside the gluons and puons, all that shit, all the neutrinos, all that crap, all those things are collections of the quanta, which are really just gravity. Okay. And then are these particles not moving in fact, but only give to the next directional information they have got from another next particle? Frankly, yes, you can turn into a matrix of squares, and just say the squares push into each other, and that push goes into the next square, and that push goes into the next square. So you can take the empty space away, but I don't think you need to. I mean, I don't necessarily think that's how it works, but it certainly could be that there is no such thing as space. There's just these things, and they're constantly going in whatever direction they have by every Planck tick of time, so to speak. In this case, it would be like air movements on the surface of the globe, tornado-like. Yeah, it's really not a good comparison just because it's not about friction and all that kind of stuff and drag, and air gets into all that kind of stuff, so I don't know if analogies are very good. And I think it's almost like it's more digital. It's more a probabilistic arrangement. Once you have an arrangement, it's about the probability of that arrangement being disrupted enough not to be able to sustain itself, not to be able to clean itself of the aberrations that might exist in it, and to maintain its condition. And so that's really the game, is just maintaining the condition. And when the condition isn't maintained, stars, supernova, and such. Well, is that bright? Oh, okay. Similar to the fishes in the fish school. Yes, well, the fish school I think is a better analogy, but yes, it's just all energy, and matter is energy. E equals mc squared. It's really just E equals m, or m equals E. Doesn't matter. Matter is just a form of energy, and the form difference is regular energy, gravitons, or photons when they're free, are just doing this straight line thing, going one place to another place in a straight line, and matter, the little bits, are trapped in orbits. That's the difference. Probably square ones. Yeah. Y square or cube in the other, like planetary gear configuration, and not round and spheric. Well, again, I think the geometry of square is more rudimentary, first off. So yes, as you go down, the geometry gets simpler. Circle is complex in the sense that I don't even think there is such a thing, technically, as a, you know, the perfect circle, or and I think pi sort of indicates that, the fact that you can't really take this number down to the smallest bits because you lose pixels. So if I go, even if I did that to this screen is made up of a lot of geometry. I mean, that's why the text has to be, you have to have an algorithm to fix the text, because the text is kind of made out of a square geometry that's trying to do round, and that doesn't work very well. But in the big picture, like I said, the higher the resolution you have, the more perfect the circle you can draw, in the sense that you can take all the little jaggedness out. But if I take an old computer that only has, you know, whatever, 500 pixels, and I draw a circle, the circle is going to look like shit. It's going to look like a bunch of squares all around the edges. So I think the fundamental, rudimentary geometry has a lot more squares in it than it has circles. Just because the idea of it is, it goes back to this dimension thing. It really is those three dimensions, and they don't have, you know, I'm not saying they're a static dimension. There's not, everything's just these three lines, but I just mean these three. The idea of the left right is really what the system operates on. Is whether something, it doesn't really care whether it's that much right or that much right. It just cares, or left, that much right or that much right. It just cares that it's in that right direction. But that gets kind of a complex thing. But I just think it's not something I have a proof for. I'm just saying that I think the geometry is easier to create out of simple particles if you make it more geometric. Geometric in the sense of square. Yeah, okay, so did that. Alright, the two slit thing. Alright, so yeah, I won't read, I guess, what I've started with. It's not, you know, it's not bad, but it's just not enough yet, you know. But I'm doing, so the paper will be on the subject of reasonable interpretation of the two slit experiment, and I just basically point out how, you know, it's all voodoo. Using water as a comparison, not a great idea. And that ultimately it's about the surfaces, not the slits. Stupid. And that's where I'll get into all the details. You know, and the first fundamental detail is that idea that in the two slit experiment, the key difference between the single slit and the two slit experiment is that the fact that you've put surfaces in the middle. So in the strongest light, you've now put a surface, two surfaces in fact. And where in the single slit, no surface, wide open middle, so the light goes straight through. The second fact that people don't really talk about, but it's really kind of important, is if you just think of this, you know, the target's quite a ways away from where the slits are. From the target's perspective, the slits are infinitesimally small. I mean, they're just absolutely tiny. So any light that goes through is just going dead straight, you know. And it's the idea is that it's the diffracted light that goes wide. So in a sense, by going distance from the slit, you in a sense magnify the image, right? So as you go closer and closer, the image will get smaller and smaller. But what is the image an image of? It's an image of the diffracted light, the wideness of it. All the width is light that had to be diffracted. And the key is the light that went unmolested through is likely going to be right there in the middle. So all the unmolested light ends up here in the middle. It doesn't go, even if it's diffracted just a little, it's going to end up right in the middle. Because from the slit's perspective, that distance, at that distance, that middle is huge. You know, there's a huge amount of, this is a huge thing compared to this little tiny slit over here. So that's one thing that's just never talked about, is that the magnification only magnifies the diffracted light. I mean magnifies in the sense of spreads out, or however you want to describe, makes the bigness of the image is all made out of refracted light. If you didn't have any refracted light in the what you were viewing, it would just be a tiny dot, the tiniest of little dots. So it's only through diffracted light that you see anything. All right, now the big one. Drum roll, please. So I was thinking, there's single surface diffraction, but it's really fuzzy. There's not much to it. You know, it's hard to get a really good. You can do it, but it's difficult to get a really good bar pattern off a single surface. And so I was contemplating that and wondering, you know, why is it so much worse? And then why is the single slit so much weaker than the double slit experiment? And that I've sort of explained. The key is that single, you know, the most intense light now travels right next to surfaces. So more light by a significant percentage is now traveling right next to a surface in the double slit. But you know, even those explanations, it still needed something more. And it occurred to me when you know, these kind of images I'm going to be putting on you know, in here. I'll grab a couple of these good ones. But if you look at this little, you can sort of see, okay, I have the fuzziness around my fingers, and as I bring my fingers together, the fuzziness, that there's a dark lines that are formed. Those shadows represent places where the light is being diffracted, so it doesn't get to me. See, that light is not getting to you. That dark line being formed is a shadow where the light has now diffracted, so there's no light there. And just see how much stronger it gets as this fuzziness closes in on the other. You know, as the fuzzinesses meet each other, they magnify the effect. So it's almost like a very little effect and then very big effect, very big diffraction. And I think what this represents is there are these field lines around everything. And they're opposite for two slits. One's going this way, one's going that way. They won't combine, so they're compressing each other. And what you're seeing isn't the field lines. You're seeing the place where the electrons are. See where not the electrons, where the flow is, where the stuff won't stay. So where the iron filings won't stay because there's energy there. They're going to be pushed to one field line or pushed to the other. The quiet space. The field lines are the quiet space. Well, anyway, the point is when you're pushing your fingers together, what happens is those field lines interact. They're not compatible, and they compress each other. And as they compress each other, it narrows the lens, so to speak. So you can almost think of if those field lines just represent a little bulge, you know, so the lines are here, and in between the lines there's a bulge, which is the capacity to carry current that's, you know, flowing around everything. The charge, that's the static charge that's flowing around everything. And as you bend those field lines or push them, compress them, what you're doing is increasing that bulge. And that's what's increasing the diffraction. So in single slit diffraction, as I make the slit narrower and narrower, the pattern gets wider and wider. So the narrower I go, the wider and wider the diffraction. And the reason is because I'm compressing those field lines, and the compression is being caused by the fact that the two slits are coming together. So now I'm multiplying how many field lines also, in a sense. You know, they start off the same, but I mean, I'm pushing more and more of them into direct contact with the center light. More of them are moving into the center light because they're getting compressed narrower and narrower. So the brighter the light in the center is the light now that's going to have more and more of those field lines in it, because those are the first ones that are going to compress. The outside ones will compress first, and they're going to be in the middle. So as you push the two things together, you compress those lines and essentially make more eccentric lenses that diffract the light more severely. And it's all proportional, of course. So, you know, the pattern is retained. All that's changed is the angle of diffraction. As I bend this, as I go from this little hill to this bigger hill, it's quite obvious something going in here. With the little hill, it would go like that, but with the bigger hill, a straight line is now going to be over here. So it's all about taking a straight line off that hill. And that'll tell you, you know, a perpendicular line off the surface. It's the same as the prism. It's the same mathematics and relationship. And so I figured that's pretty much the slam dunk here, right? I mean, I think we have it. And like I said, when I can do such a simple experiment to demonstrate it, you just know I mean, I can see that in the camera. You've got to be able to see it. You see all that darkness being created between my fingers? That's it, right? Those are the field lines compressing and now diffracting the light more eccentrically, and so now it doesn't get to the camera because it's being sent somewhere else. It can't get to the camera lens because the diffraction angle is higher. So yeah, good job, Gary. Yeah, I mean, probably if you could actually have an image in between my fingers that you could actually resolve, you could probably see that it distorts it before it actually makes it impossible to see. There's probably some distortion before it becomes totally impossible to read, but that's a little more complex of an experiment. Yeah, so have I done my job here? I don't know if there's any other details that are significant. Let me just check my working paper. But yeah, it's really about the surfaces. So, you know, with one surface, you have one surface. With single slit diffraction, you really have two surfaces. And two slit diffraction is four surfaces, and now they're in the most intense part of the light. But, you know, this is already something I've pointed out, that when you do single slit diffraction with lasers, you know, and you don't use an aperture to spread the light, you have a much more consistent beam of light, and the pattern is much brighter. And that's because you don't have any weak light at the edge, so now the stuff hitting the surfaces in the two slit experiment is a much higher percentage of the overall light. So you got to recognize that when they originally did the two slit experiment, they always used light that went through an aperture, which means it was coned light. I mean, it had a peak intensity at the center and a weaker intensity at the fringes. And that's a huge difference. And, you know, they don't account for any of this with the math, which is also kind of funny. You know, that there's no accounting for the source of the light. So they're doing math without paying any attention to this light source. And it's not going to affect where the bar patterns are, but the intensity of light surely will affect how bright the central maxima is compared to the other bars. And I think that's clearly, without counting on that, single slit diffraction can be of various reveals depending on what light you use. You use certain light, you'll see it quite obviously, and you use some other light, it's not so obvious because of that effect of coning the light and making the central maxima even brighter. So, yeah, so obvious things. Matter is not a solid surface. You know, this stuff should have occurred to somebody. I shouldn't have to say things like that, right? The physicists should already know this, right? That matter's not like a smooth thing and the light just travels by it, nothing, no problem. Again, it's as simple as this. I mean, you just can't get any easier than just doing this, and you can just see how. And they already knew this about shadows. They already knew there was a fringe around every shadow cast. There's a fringe. I mean, that's telling you something, isn't it? Yeah, it is. Center impediment creates maximum surface contact. So yeah, that's the part I already did. you know, the distance from the target only magnifies diffracted light. So as you increase the distance, all you're doing is magnifying the diffracted light. The light that is unmolested went straight through and is right in that center maxima, and it's, you know, it can't miss. It, you know, so that's why the center maxima is brighter, is only because all the non-diffracted light goes there. Yeah. Okay. So I think that's good. I don't think I need to do more. There's more I'd like to talk about, but you know, I'm just a bit discouraged. But you know, what are you gonna do? I mean, a lot of other, not for this subject reason, just life in general and people in general, and you know, everybody is such an obnoxious shithead and so fucking goddamn stupid, and also insanely. I mean, you know, they're just look. I mean, it's like these people. You know, there's also the other guy with the whatever it is. He has a great name. I have to concede. What's his face? You know, I have a link to it here. I just go to the page because I can't remember it. His name's probably not on here though. Well, anyway, yeah, I don't see it here. I'd have to go to his other page. Well, whenever, this guy who writes all these papers. Yeah, he's just not writing much anymore. I mean, every week for over a year, and then, well, I mean, generally speaking, his average over the last 5 or 10 years has been like a paper every 2 weeks, I guess. And wow, he's just really, you know, not much anymore. But I guess he's getting married or something, so maybe that's fucked him. Anyway, we'll assume it's something like that. But they're also arrogant, and not that I'm not, but you know, I'm right, so I'm allowed to be arrogant. You know, and just the idea of, you know, I'm giving you like something real. I mean, I'm explaining the force. You know, this stupid photographer guy keeps saying, well, none of these quantum people. Yeah, well, he's debating the dead ones. He's debating the ones I agree that are wrong right now talking. But fields can be explained by somebody who does believe in a quantizable material universe. Material energy can be explained by somebody who understands it, and I do. So I can explain it to you. Anyway. But it's not like it's that far off. Like, again, Tesla believed in a ether, in a matrix of stuff in space. Space wasn't nothing, it was a something. And the only thing he did wrong was not realize that that ether wasn't a dead medium, like a dead, quiet pond, that it was in fact an energy. So it was full of energy already. It wasn't just conveying energy, it was full of energy. It could do both things. You could pull energy out of it. Obviously you got to put it back someday. Conservation, like gravity. Gravity is so obvious in terms of the conservation, right? Whatever you get from gravity, you have to give it back if you try to leave. You know, you can only use it locally, and then you have to give it back. You know, you get the first one free, so to speak, with gravity, right? You get to fall off the building for free, only because you climbed up the building, right? Yeah, that kind of thing. Yeah, so there's not much. What else do I want to say about that? But yeah, you know, Tesla was almost there if he would have just said, well, what if, you know, I give this ether energy to move planets? Bingo. But at the same time, I can send things across it. Things can travel through it without being at all irritated, no friction, because the stuff is going to be made out of the same stuff the ether is, and it'll just travel right through the ether. Energy travels through energy, that kind of thing. You know, but you know, getting to the polarization thing, that's when it don't work no more. Magnetism, electricity, that's the limitation. But see, that's, Tesla wrong again. I mean, he thought he could just send this electricity thing anywhere he wanted to, and that it didn't have to burn its way there. But it has to. It has to have a path, and there's no path in space, and unless there's matter there to provide you the path. You have to put matter. Electricity just can't go anywhere. It needs bits of matter. It needs nuclear bits, not quanta, nuclear bits, to be able to connect the dots. You can only jump so much of a gap at a time. I mean, that's the funny thing about lightning, right? It looks like it's jumping a huge gap from the cloud to the ground. But what it's really doing is jumping whole bunch of little gaps. Yeah, just looks like it's doing a big thing. It's really just doing a lot of little things. So anyway, that's why it makes its path first. It collects a bunch of particles and ions in a row, and then it zaps the fuck out of them. Just burns them up. Fries their asses. So lightning basically makes itself an electrical wire, and then it fucking burns it to pieces by using it. I mean, I got all this stuff. It's just got it all nailed. And when it's all said and done, 14 Nobel Prizes, something like that. 14. Nobody's gonna beat my records. They say that in every sport, right? Yeah. But no one's gonna do. No one's gonna. There's no undo. There's no. Yeah, I don't know how to explain this, but I'm sitting on top of this and I'm saying, all right, yeah, I got all this physics shit. I figured out that life is stupid. Your brain is just a bunch of bullshit asshole programs running. Who's going to top all of it? I mean, I've solved every meaningful question. I've answered it. We're just so fucking done. Oh, God. I don't even know how to analogize it. How do I properly put into perspective how Michael Jordan the universe. I mean, I just fucking owned it. Anyway. Yeah, no, I can't comb my hair, but apparently I can answer questions. Certain questions about certain things. Like important ones about important things. Yeah. Can't stop fruit flies from eating my orange peels. Yeah, it's true. I can barely function on an animalistic level. I'm just barely eking out survival. But apparently all this stuff I've been doing for all these years on this planet, thinking, paid off. Go figure. So anyway, enough of that. Yeah, it's just, I know, it sounds, I mean, I laugh at it too. Yeah, just because you look at these assholes, and they're pretty much assholes on the internet, talking this multi-dimensional time and all this other kind of crap, and they're just, like, again, just, oh, look, I've got it in magic. And they're just such arrogant assholes. And I'm being one of them. But the difference is, I want the argument. Come on, bring me some challenge. Show me some fact that I'm not going to be able to overcome. And you're just not. I mean, you can show me some scientist says, well, so what? Show me a real experiment. One that's not going to take me 5 years, like the Higgs boson or something. Yeah, okay, I'm not going to spend 5 years analyzing 7 million images of little squirrely things flying through a cloud chamber. No, I'm not doing that. And what they surmise that's a baby of the cousin of the nephew of the Higgs. So that must be a Higgs there, right? I mean, if you have the cousin and the nephew and the uncle, then you must have the inbred. Oh, yeah, yeah, right. The mutant child. Or whatever. I mean, some surmises, there's a vagina particle and there's a penis particle. Yes, okay, you might buy that could happen, but no, this stuff. They're just making a lot of this crap up. So that's where we all agree. They, the institutional physics, is full of shit. But unfortunately, these non-institutional physicists are also full of shit.